We good to go? Okay. If you're a front-end or mobile app developer, you'll know this moment well. A user taps a button on their device and expects something to just happen instantly. A vote to count, a message to send, a feed to update, live location to move, no refresh, no spinning wheel, no delay. Real-time experiences aren't just nice to have anymore. They're really baked into user expectations, and delivering that on, say, mobile, where you're juggling battery life, latency, low bandwidth environments, unreliable networks, it's hard. And add to that the challenge of maintaining and sending to mobile devices, things get complex quickly. However, in this session, we're going to shift your mindset away from the idea that building real-time applications is hard. You'll learn how to build a fully managed, serverless, and secure real-time API using AWS AppSync. We'll talk about how to use it, how it works, and also some common patterns and architectures that we see customers already building today. My name is Zach Burns. I'm a senior solutions architect at AWS, supporting our UK and Irish startup customers. I'm also a serverless SME. And joining me on stage today is my colleague, Ozzy.
Hello, everyone. My name is Ozioma Ozegu. I'm a principal solution architect here at AWS, where I work with our financial services customers across EMEA. I'm also part of the field team responsible for helping our customers adopt services like AWS AppSync, Amplify, and other developer services as well. Over to you, Zach.
Thanks, Ozzy. So let's talk about those user expectations that I referred to. So on the left, we've got a typical mobile experience that many users are still stuck with today, polling for updates every few minutes. So you might not notice the delay if you're just periodically checking the scores or the stats of a game, but in fast-moving situations like live sports, auctions, collaborative applications, a 2-minute delay might as well be 2 hours, right? The user experience is ruined at that point. So on the right, we've got the same app, same data, but with real time. Scores change as they happen. No refresh, no waiting about, just a seamless experience that keeps users engaged and coming back to your application. So this shift from polling to real time is what users want. So I want to cover some common examples when it comes to real-time. Right? There's a lot of different categories that real-time can fall into, but I want to cover two of the most common ones. Event broadcast is, again, very popular. So this is when you would have hundreds, if not thousands, of subscribed clients listening for updates on your data. Some common examples are, again, sports scoring applications, maybe price changes on e-commerce sites, betting odds applications, online voting, group messaging, etc. Collaboration as well is incredibly important, especially in the ever-increasing virtual world that we're moving into today. And again, these type of applications include document editing, location updates, multi-turn gameplay, shared music queues, etc., etc. But like I said, building real-time applications is hard, right? You could take the conventional approach and build a polling type system, but you then increase latencies, right? Data is not fresh. Users aren't getting data as and when it changes. They may have to scroll down and ask for it themselves. There's also that possibility of unnecessary resource usage. So, what if you have an upstream data source that's not changing or delivering data too frequently, and you have users constantly asking for updates and it's not changing? That's excessive compute use. That's extra cost you don't necessarily need to incur. And of course, scalability. Again, what if you have that feature that allows a user to request updates and every user does that at the same time? How do you account for that level of scalability, right? It's quite tough. You could then move to WebSockets and deliver that really nice real-time experience. But it's also hard. It's very complex, actually. You have to think about connection management. So when a user connects to your WebSocket, where do you store that information about that user or that connection? How do you look that up? How do you fan out to all users? And of course, scalability as well. How do you build a WebSocket that can handle 100 users versus 1 million users if you need to go up that much? And either way, there's a lot of back-end code, there's a lot of undifferentiated heavy lifting just to get a basic WebSocket application. You have to think about who can subscribe to what endpoint, who can publish to what endpoint, what does the data look like? And of course, observability. It's always a challenge if you're building an application from the ground up. So on AWS, we of course already have a number of solutions available to start building real-time applications with. Amazon API Gateway, for example, it's not just a service for exposing HTTP or RESTful endpoints. You can also deploy a WebSocket endpoint from API Gateway. Again, it's serverless, fully managed, a lot of nice features straight out of the box. You do have to manage the infrastructure around connection management. So when a user connects, you have to maybe invoke a Lambda function, store that in a DynamoDB table. If you want to send a message to that user, scan the table, get that information, fire it out. A lot of moving parts for the connection side. So sometimes people want a more managed solution. So we can look at IoT Core. Again, very nice managed MQTT broker style WebSocket experience. Again, very, very popular. But we do typically say it's better for fleets of devices, dashboards, things like that. And of course, what we're here to talk about today, AppSync and GraphQL. So GraphQL does support real-time through subscriptions. Again, very nice features out of the box, but it does use GraphQL. Again, not an issue if you're well immersed in that world and you're already building with GraphQL, but sometimes people don't want to go down that route for whatever reason. So about a year ago, we asked customers like yourselves, developers, architects, mobile developers, what would make AppSync subscriptions even better? And we got some very nice feedback around, again, observability, DR, multi-region support for endpoints. But the standout ask by far was for an event API that doesn't use GraphQL. And so that's what we delivered. Around the end of October last year, we launched AppSync Events. And this is a fully managed, pure WebSocket-based API with managed pub sub, authentication, connection management, fan-out capabilities, data sources. And it's not within the GraphQL world. You don't need to build the design schemas to start building real-time applications. So we're feeling a bit brave. We're testing the demo gods today. And a good way to learn about a new service or a new feature is to build it, get your hands dirty, have a bit of fun. So all being well, you scan this QR code. It should bring you to a page where you can choose your favorite sports. There's also this QR code on the website. So if you want to flick that over, you can scan the top right. But yeah, if everyone could just choose their sports, you can change your mind as well. We want to really hammer that. We want to show the scalability. Again, we talk about being able to do millions of messages per second, millions of connections. So yeah, if everyone wants to pick their favorite sport, change their mind, have a bit of fun, yeah, it's good to see. So football, F1, golf, that was my three. It's good to see. Basketball's obviously there. Nice. So guys, you can see the votes hammering up, right? Again, this is a very small use case, but again, extremely scalable and just a bit of fun. If you want to build anything on AWS, build a demo, build a simple fun POC, and that's what we did. Tennis now making a comeback, awesome. Cool, and this is stateless, right? So if I was to refresh this page, we would lose everything. We'll talk about a pattern, how to not make that happen, because in the real world, that's not going to be a thing we want to do. So if we could go back to the slides, please. And yeah, thanks to the demo gods. That was a bit of stress. So I just want to very quickly cover how I built this, and Ozzy will come onto the stage and go into the depths of AppSync Events, but I just want to highlight how simple it is to get started and build a POC. So this is the code to connect to the WebSocket client, and I'm importing the events class from the Amplify library. So for those that might not be familiar with what Amplify is, it's essentially a service that really helps you accelerate full stack application development. So it has things like hosting. So that demo that we were at, that was hosted on Amplify, so you can point it at your GitHub, for example, and it'll do all the building, compiling, and deployment for you, fully serverless. It also has a very nice CLI toolchain, so I can do things like Amplify add auth, it'll create a Cognito user pull for me, Amplify add API, it'll deploy a RESTful endpoint GraphQL event API for me, all very nice stuff. And of course, an SDK, or a bunch of libraries to connect the front end and the back end together, and that's what we're doing here. So very simply, again, I'm just using the events.connect function, specifying my channel. We'll talk more on what that is, basically where I want to listen for updates. We specify the AppSync endpoint that it gives us and our means of authorization, and that's pretty much it. To publish a message, again, we just use the publish function from events, the events SDK, or the events library. We specify where we want to publish that event to, the payload itself, and of course, how you want to authenticate that. Yeah, again, very, very simple to get started. And this is the architecture. I'll give everyone a second to take this in because I know it's complex. Joking, of course, that's the idea, right? It's designed to be simple. We don't need all these different moving parts and ways to manage connections and fan out connections and authorization and everything. It's all contained within AppSync and AppSync events itself. So again, very, very simple to do. So that was a very warm intro to AppSync events and why it was introduced, but I'm now going to welcome Ozzy to the stage to really go into the details on how to build an event API. Ozzy.
Thank you so much, Zach. It was really great to see quite a number of football supporters in the house as well. I'm a big football fan, but could see tennis taking up the lead as well a couple of times. But I think Zach did a good job kind of covering, showing a real-time application built with AWS AppSync events. And I know for a couple of you in the room, you have a big question now, how do you actually go started building with AppSync events? But before we dive deep into how it works, there's a number of concepts you need to understand about AppSync Events API. So when you set up your AppSync Events API, you have this concept of namespaces. Think about namespaces as a way for you to define the behaviors and ways and the capabilities of the channels within your namespace. So when you create your AppSync Events API, you typically get a default namespace, but you have the flexibility of creating more namespaces as well. For example, for our sports app, so we are creating namespaces like basketball, football, and tennis to represent the different streams we want to send events to. And then you've got your channels. Think about your channels as a routing mechanism to publish events from your publishers to your subscribers. So channels are ephemeral, you can create them on demand, and you can think about them as a topic or a subject that related events kind of belong to. And if you see, the name of a channel is typically a part. And the first segment of that part is the name of the namespace the channel belongs to. So namespace channels, key concept to understand when you are building your event API. Now we've got the basics out of the way. Let's start thinking about like how do you go ahead publishing and subscribing to your AppSync Events API. So when you create an AppSync Events API, AWS will generate two endpoints for you. So the first is the HTTP endpoint. This is your typical HTTP endpoint. There's nothing different here. It contains an endpoint identifier and also the region where you've deployed your API. We also generate a WebSocket endpoint. But I think the good thing here is that these endpoints are generated. You can also bring your own custom domain. Think about it as a friendly domain that you can use to configure on your HTTP endpoint or your WebSocket endpoint to make it easily recognizable. So with these two endpoints, you can get going. So the publisher can publish to your Events API via HTTP or WebSocket. Think about events as a JSON payload with 240 kilobytes of max size. And then you have your subscribers. So your subscribers can connect via WebSocket, and then they start receiving events. Let's go through a typical flow of how you can think about building this and implementing this for your use case. So let's look at, we have two subscribers here, subscriber A and subscriber B. First, they need to connect via WebSocket to a channel endpoint. So the channel we have here is football/scores. So any event generated, they will be able to receive that once they subscribe. And then for the publisher, you have two options of the way you can publish. You can publish via HTTP posts to the channel, to your WebSocket endpoint, to your API endpoint, and this is the example of what that looks like. So you can see what we've done here is, this is a simple HTTP post where on the body of your HTTP, you have the channel details of where you want to publish to, and also the event payload that contains the event you want to send to the subscribers. Just over a month ago, we announced the ability for you to also publish via WebSocket. In my view, this is a game changer for developers building real-time application. Because what that then means is that AppSync events is now bidirectional. You can publish and subscribe via a single WebSocket endpoint. You no longer need to maintain a HTTP endpoint for publishing and a WebSocket endpoint for subscribing. You can do that via a single WebSocket endpoint. And here is a sample of what that looks like. So you kind of define a unique ID for your message, the type of the message, and of course, the payload you want to send to your subscribers, specifying the channel you want to send that through as well. And when you set this up, you have the flow. Publishers begin to publish events, just like all of you were publishing via the Vote app, and that will get to the subscribers, which in this case can be a dashboard visualizing the votes we just went through now. But it doesn't stop there. Remember what I mentioned. Your subscribers can also be a publisher. So our subscriber A can also be a publisher because they can now publish events via that WebSocket endpoint. And any subscriber, in this case subscriber B, connected to the channel will be able to receive those events. Now, let's look at a simple demo of what this looks like for you to get started creating your own events API. So we're going to go to the AWS console. If you have not used AppSync before, you can quickly go on the top search bar to just search AWS AppSync. You'll be able to click that, and that takes you down to the AWS AppSync console. We're going to create a new event API. We give it a name called Scores API in this instance. So this is representing that we are creating a new API. We leave every other thing as default, and we click Create. Once you create your API, you can see a number of links to kind of help you go to the features of the service. But what you also see there is an embedded CloudWatch metrics that gives you visibility into how folks are invoking your API as well. If we go to the settings page, this is where you see the details about your API. You see the details, the name of the API and some IDs, but the two endpoints I talked about, the HTTP endpoint and the real-time endpoint, this is what you really need to begin to integrate to your API as well. We'll cover a number of other things on that settings page for now, but let's kind of go to the namespace. If you remember what we talked about around namespace, you get a default namespace, but you can also create your own namespace. So what we're going to create here is a football namespace, being a bit biased with football. And then once you create that namespace, you can begin to test your API. So we provide you an editor within the console to actually begin to test the API you've just created to see how your events are going to be published. So on the console, you can see we have a publish section that kind of you can use to begin to publish event. This is simulating a publisher. And also, if you scroll down, that's the publish section. If you scroll down, you'll be able to publish via HTTP or WebSockets, but we also give you like a subscribe client. So think about this as a client subscribing to the API. So what we're going to do here is to create a new channel for Scores and then subscribe to that channel as well. You can see we got a success for the subscription. This is a client subscribing to our API to be able to receive any event published to that endpoint. What we're going to do now is to publish a payload. So this is simulating a football score between two matches going on in parallel between red and blue team and yellow and orange team. We've published via WebSocket. And you can see we got a success there that this event is published. But when you go down to the subscriber section, you'll be able to see those events payload actually sent to the clients that have subscribed to the event, which is in this case is all done from the console. This is simulating your client subscribing to your API. The same thing happens as well if we publish via WebSocket. So you can publish via HTTP or WebSocket, and you can see the similar thing as well, all the events coming through. So you can begin to validate that your setup is working before you actually implement this within your application. And when you start thinking about implementation, you can see the implementation guide tab there, where we provide you code snippets using Amplify libraries on how you can begin to integrate Event API to your application. Of course, you mustn't use Amplify as a library. You can use any other library of your choice with those two endpoints we've just talked about as well. So this is showing you code snippet for you to connect to the API, to subscribe, and to publish to the endpoint as well. So this is how you get started creating your Event API. But if you think about what we've talked about so far, it looked like this is almost like a pass-through scenario where you publish events and then the subscribers receive it. But there might be cases where you might want to intercept that event. Say, for example, you want to do things like event transformation, You want to store the event in the database, for example. And also for your subscribers, when they are initiating a subscription request to your endpoint, you might want to intercept that subscription request to do things like granular authorization or potentially to log that as a log, for example. And that is why we built event handlers on AWS AppSync Events API. So what is it all about? So again, we have our API laid out, our namespace and our channels and our publishers and subscribers. So within the namespace, you can define the unpublished event handler. Think about this event handler as a function that intercepts any event that is published by the publisher. And within that function, you can begin to do transformation of your events before they are sent to the subscriber. We also have got the unsubscribe event handler. So this will intercept any subscription request to your AppSync Events API, and then you can do things like granular authorization or potentially log that as well, or do subscription filtering with that request. So let us go through how you can go about implementing with event handlers. There are basically two options you have. So when we build event handlers, you can basically define the transformation you want to happen as part of that publish or subscribe right within your AppSync JavaScript runtime within your AppSync API. But just last week, we announced the ability for you to now integrate your event handler logic with data source. And I think this really opens the opportunity for customers to do more with publishing and subscribing. And we'll dive a little bit deeper into how that works as well. So let's start with the option one. So for the option one, where you can publish, where you can define an event handler with no access to data source. This is an example of what that could look like. So this is a use case where we are publishing an event. This event payload don't have maybe a timestamp of when that event was generated. You can use the AppSync util libraries to add a timestamp as part of the payload of the event, and that will be sent to the subscribers in addition to the initial payload of the event. And then for the subscriber as well, you have the unsubscriber events handler. What's the code here, what we are basically doing is to implement fine-grained authorization, where we are ensuring that the username of the user initiating the subscription request matches one of the names within the part of the channel name. So remember, we talked about the channel being a part, the name of a channel being a part. So you're doing that granular authorization to make sure that the user subscribing to your API, the name matches, so that you make sure they're subscribing to the right channel, and they can only receive the messages that is due for them as well. So you can implement this level of granularity in terms of your authorization for your AppSync Events API. But for me, where it gets really interesting is really when you begin to think about integrating this to different data sources. So if you lay down your AppSync Event API again, we've got our publishers and our subscribers. These are all the data sources that you can integrate with your API. So Amazon DynamoDB, Aurora PostgreSQL, OpenSearch Service, Amazon Bedrock, Amazon Event Bridge, and AWS Lambda. And you can also invoke a HTTP endpoint as part of your event handler. So customers have asked for this feature for quite a while now. And these are the typical use cases we see customers using this feature. So the first one is around event persistence. Because when those events are being sent from the publisher to the subscriber, you might want to intercept that event. Another key use case is around event processing. So if you want to carry out like complex transformation of the events before they actually send to the subscriber, you can also do that with triggering a Lambda function, for example. Think about event-driven patterns. With the integration with Event Bridge, you can begin to think about some event-driven architecture for your use case. And finally, that granular authorization we talked about. For example, if your user data is on DynamoDB or potentially on PostgreSQL, you might want to integrate to those data sources to retrieve those user details to perform your authorization before you allow that subscription request. I can't go through all the examples of all the data sources, but I want to call out two key ones, which we've seen quite popular with a lot of customers. And that's with event persistence with DynamoDB. Say, for example, as events is being generated, you want to store that in the DynamoDB for you to replay it, say, later on, before sending that to the subscriber. And this is a simple code snippet that does that. So this is within your event handler, you are pushing that event using the utility libraries we provide on AppSync to store that in DynamoDB before sending that to the subscriber. That's what you do within the response. Another big use case we're seeing is around invoking Lambda function with your event handler. And this is where it begins to get interesting. So if you think about that event moving from the publisher to the subscriber, you can actually invoke a Lambda function both synchronously or asynchronously to do some level of transformation of the event with any programming language of your choice, given that it's running on Lambda, or to potentially trigger an external workflow as part of generating that event. So we provide these options of asynchronous and synchronous invocation from the event handler. And this is what that code snippet looks like in terms of how you implement this and the various options you have as well for invoking Lambda right within your event handler. But you can also do this directly, bypassing any logic within the onPublish handler and just invoke Lambda directly for folks that don't really want to get accustomed with AppSync JavaScript runtime and just want to invoke Lambda to process the event before sending that to the subscriber. The direct integration with Lambda is also another option you have to be able to do that. And what that looks like is the event, which has been published, will be a parameter to your event handler, and you'll be able to kind of perform complex transformation on that event before you send that down to the subscribers. One of the things you need to think about when you begin to build your event API is around authorization and authentication. It's really important because you want to make sure that only the allowed publishers can publish and only the allowed subscribers can subscribe to your event API. So with Event API, we support 5 ways to implement authorization. If you have your users within Amazon Cognito user pool, you can use Cognito as your IDP. API keys, we only recommend that for test and dev, not for production use case. And if you have a custom logic for your authorization, you can build that with Lambda and use Lambda authorization, integrate with AppSync Event API. But if you use IDPs like Okta or Auth0 or any other OpenID compliant IDP, you can also integrate that with your Event API. And finally, AWS in Identity and Access Management. So if you think about resources within your AWS account, for example, an EC2 instance, a Lambda or event bridge that might want to publish an event to the endpoint, is recommended to use AWS IAM to authorize those requests. And when you are building your event API, there are kind of 2 key concepts you need to think about in how you implement authorization. You can define that at the API level, which will apply to all the namespaces and all the channels, but you can also go a bit granular and implement your authorization at the namespace level. Why might you want to do this? So if you think about the publisher, you might want a case where you have a different authorization mechanism for your publisher and a different authorization mechanism for your subscribers. Say, for example, we have AWS resources like Lambda, Event Bridge, or EC2 that are the publishers. You might want to implement authorization of those resources using AWS IAM. But if your subscribers are web clients or mobile clients, for example, you may want to use things like Amazon Cognito User Pool or any OpenID compliant IDP to be able to implement those authorizations. So you can do that at the namespace level, specifying which auths to use based on your use case and for your application as well. Let's go through a quick demo of what this looks like. So we're going to go back to our Scores API that we've just created. So we go there, and what we're going to do is to look at the authorization. So you see within the AppSync console, we provide you a way to define the authorization. Currently, we are using API key. This is for test and dev. But you can also add additional authorization to your API. Those 5 authorization types I've also talked about. So what you can also do is to go back to your namespace. So you can define your auth at the namespace as well. We'll quickly edit our namespace to see how you can do that. So once we edit our namespace, you see the option within your namespace to actually enable authorization for that namespace. So this is us doing it at the namespace level. So you can see you can specify a different auth for the publisher and also a different auth for the subscriber. And this will flow through any auth you've already configured on your AppSync API. On the API level, you'll see that all reflected here as auth modes to select based if you're doing publishing or subscribing. What we've also got here is kind of showcasing that event handler we talked about. So you can define your event handler with code, accessing a data source, or potentially no data source as well. The first option we want to go for is using no data source. So what we're going to do here is to basically update the event payload, adding a timestamp. So this is where the event didn't have an event and didn't have a timestamp, and we're adding one. So what we're going to do now is to publish a sample event to see what happens once we add a new timestamp as part of that event handler. So we're going to subscribe to the channel. So the subscription is successful. And what we're going to do now is to publish via HTTP. So this is successful as well. You can see that's published. What you see in the subscriber section is that we are not only sending scores now, we are also sending a timestamp as part of the event reaching the subscribers in this instance. So you can with the event handler, what we basically did was to define a simple code to add that feature. But what we can also do is to connect to a data source. A typical example might be where you will want to store the event in a DynamoDB or in a data store before sending that to your subscribers. So what we're going to do here is to first create a data source that we want to store the events on. So I already have a DynamoDB here, DynamoDB table here. And if I quickly explore the table, you can see that this table is currently empty. There is no data on this table. So we'll go back. Within our API, what we're going to do is to add the DynamoDB as a data source to our API. It's quite simple. Give the data source a name, select the particular data source you want to add to your API, in this case, DynamoDB. And then what we're going to do next is to specify the table of the DynamoDB, and then it's within our API. So once we create the data source within our API, what we'll do next is to define the logic to store the data in that data source. And that's what we're going to do within our event handler. So within our event handler, what we're basically doing here is to add our data source and write a simple code snippet here to store those events to our DynamoDB table. So I'll quickly paste the code here to do that as well. So this is the option where you want to make sure you retain that event, say, for example, for playback or for any of the use case. So you can see what we are doing here. We are specifying the DynamoDB table and then specifying how to store that using the batch puts within DynamoDB, but also adding two new variables, the channel, the timestamp to that event payload, and then sending that to our subscriber. What we're going to do next is to test this. Let's test this and look at what it looks like now. So we're going to put back our usual match score payload as our event, subscribe that to our scores, and then what we're going to do is to publish that event and see what it looks like in terms of what is sent to the subscribers. So we publish via WebSockets. That's successful as well. And when we scroll down, you see a number of things. So we don't just send the match scores, but we also send the channel name and the timestamp, which is part of the things we added as part of the event payload. But when we go to the DynamoDB table, you also see that we didn't just only send the events, we also saved that in a DynamoDB table. And you can see that event payload stored within DynamoDB as well for things like playback and other use case you might have as well. Cool. A customer, PGA Tour is a customer that have adopted AppSync to provide real-time fan experience to their customers. So PGA Tour redesigned their application, moving from polling updates to pushing updates directly to their fans across the globe. They are on a mission to provide the best, reliable, and most accurate scores data across all the tours happening globally. And they chose AppSync to do that because of the ability to fan out to millions of subscribers across the globe, providing that real-time experience for their customers, even though they might not be in the tour where it's happening. I'll now bring on my colleague Zach to kind of talk through some of the real-world and real-time architecture patterns we are seeing with our customers.
Thanks a lot, Ozzy. So by now we should all be experts in AppSync events, right? So now we want to put that into practice and really talk about how to build real-world scenarios using other AWS services as well. So I talked briefly about event broadcast patterns and the different use cases, but how can we build an actual solution around this? So let's look through the lens of a betting application, right? We want to stream odd updates to clients on their mobile devices. So let's think there's some upstream AI/ML service that's crunching all the numbers, that's giving them odds, and we stream those into our architecture and our infrastructure. That could be a Kinesis data stream, it could be a DynamoDB stream if we're putting them in a DynamoDB table. And of course, we need a way to get the data out of those streams, so we can use a Lambda function. Lambda gets the event from these streams, parses it, gets the odds, and then very simply makes a post request to the AppSync Events API endpoint. And very simply, any client that is subscribed to these endpoints will get those updates. And again, there's no complex infrastructure needed around the ability to do things like event broadcasting and fan out. It's all done within the service itself. Another way to do event broadcasting is to just build on top of an existing event bus within Amazon Event Bridge. So let's say you need to evolve or scale the sources of data on your front-end application that Event Bridge is already delivering. You can just configure an API destination at the endpoint of the Events API, whatever authorization it is, and then whatever patterns you're matching, you can just ship that onto the Events API and start delivering them to any connected clients. Again, really simple to do. Client to client, again, another common pattern that customers are doing, and this is when clients are essentially publishing events to and from each other, and this bi-directional communication that Ozzy talked about really enables this and makes this possible. Think of 1v1 gameplay, for example, where you play against an opponent. You need to be aware of every move that they're making at real time so that you can act accordingly, right? And there's a lot of other use cases why you might want to do client to client, for example. So referring back to the demo I did, I mentioned that it wasn't persistent, it was stateless, so if we were to refresh the page, we would lose everyone's votes. And in a real world scenario, you don't want to do that, okay? So if we were to build event persistence into that application, into that voting application, how do we do it? So everyone had their client application, they scanned the QR code and they got up the voting screen, right? As we did before, we click our votes, we stream the events through the WebSocket endpoint. But as Ozzy mentioned, we introduced data sources, so we can actually catch those events, those votes, store them very simply in our DynamoDB table, persist them, and then pass that back to the client that was listening for those updates, the chart we've seen behind me, to get those events in real time. And of course, if you want to, capture the events again or reload the screen, if someone wants to come back and look at those results, you can just make a direct call out to the DynamoDB table and load all those results in. If you were to apply this to a chat application, for example, again, you could just load the previous chat history or context, pull that into the client app and continue as normal. And of course, we can't do a talk without talking about generative AI or LLMs, right? So how can we get outputs from large language models to our clients through AppSync events? Again, very simple. So in this case, we would create essentially a dedicated response channel. And when we load the page, our client's going to connect to that channel to get those updates, right? And then when we're ready to send our prompt to the LLM, we can publish that to a direct publish channel. And on this publish channel, we're going to have a Lambda handler, which will, again, capture that prompt, call out to Bedrock, whatever LLM we choose, but we can use a really nice feature of Lambda called response streaming. And what this means is that whenever the request goes to the LLM, we don't need to wait 25, 30 seconds for the whole response to be collected and shipped back to Lambda. We can get the chunks of text as and when they're created, streamed back into our Lambda function. And then, of course, whenever AppSync or our Lambda function gets those chunks of text, we can just publish them directly to any subscribed client. And these are very nicely streamed back to the client at real time, giving that very nice, seamless chat interface experience. So that was some quick fire patterns on using AppSync events in the real world. And I'm going to hand over to Ozzy one more time just to close out the session. Thank you very much.
Thank you so much, Zach. There's one thing I would like everyone in the room to take out from the session today, and is that AppSync Events API is the easiest way for you to build and scale real-time experiences for your applications. And there are a number of reasons for that. We talked about, first, how it's easy to get started creating your AppSync Events API, with being able to publish via HTTP endpoint or WebSocket endpoints, or subscribing via WebSocket as well. AppSync Events API supports any scale. We provide you a default quota to publish to 1 million subscribers per second, and this quota is adjustable. In terms of publishing, you can also have 10,000 publishing per second. So this is inbound message to your Events API endpoint, and this is also adjustable. So based on your use case, we can work together to make sure we set up your API to meet your requirements. Our aim is to make sure you have a reduced ops, so all the features we've provided, like event handlers, integration to logs, metrics, make sure that you focus on your business logic and what you want to, the experience you want to provide for your customers. And finally, low cost. AppSync Events API is serverless, so you only pay when we kind of carry out your API operations, or also when your subscribers are maintaining a connection to the AppSync endpoint. And all the details about this are all on the documentation and all our websites as well. I'll leave you with these 3 key resources. So the first is the AppSync event documentation, where you get a lot more detail that I could cover in 45 minutes. And then Amplify clients that Zach talked about on how you can begin to integrate with AppSync Event API. And then we've recently launched a layer 2 construct, CDK construct, if you use CDK as your infrastructure as code, to help you to start quickly building with AppSync Events API. If you want to learn more about AppSync or any of the other AWS services, I'll highly recommend you visit skillbuilder.aws. Here we have over 600 free digital courses, including gameplays and workshops, hands-on lab, to help you really start learning about AWS. On behalf of myself and Zach, I want to say thank you so much for joining the session. I hope you found it useful. But hold on a minute. There's only one way we can know if you found it useful. And it's by you scanning this QR code and providing us a feedback so that we can know how the session went for you and how we can improve this session probably next year. Otherwise, I want to say a very big thank you once again, and do enjoy the rest of the summit. Thank you.